Show you off in Lambos out on Collins. I be.
Hello friends, welcome to Everything You Need. Today in this video, let us start about Gauss Law. Gauss Law states that total flux passing through the closed surface is equal to the charge enclosed by the surface. It can be mathematically given that closed surface integral of d dot ds is equal to charge enclosed, where d is equal to electric flux density. Now let us prove this using the Coulomb's law. We know that Coulomb's law is equal to F is equal to Q1 Q2 by 4 pi epsilon naught into R square R a cap. Now we know that E, which is electric field intensity, is equal to force per unit charge is equal to, here let us take Q1 and Q2 of same charge Q, that is Q by 4 pi epsilon naught times R square into AR cap. Here let us take epsilon naught into this side, that is epsilon naught into E is equal to Q by 4 pi R square into AR cap. We know that D dot D is equal to epsilon naught E, where epsilon naught is equal to permittivity of free space. That is D is equal to Q by 4 pi R square AR cap. Now let us take dot product with the ds on both sides. Take dot product of ds on both sides, that is d dot ds is equal to charge by 4 pi r square into ds into AR cap into AN, which is a unit vector. Here AR and AN are in same direction as we are considering a spherical surface. Here it is a charge Q and it is this electric field intensity. In same direction in spherical surface. So these two will be nullified, that is d dot ds is equal to charge by 4 pi r square into ds. Now let us integrate with the closed surface integral on both sides, that is closed surface integral of d dot ds is equal to closed surface integral of q by 4 pi r square into dot ds. Closed surface integral of d dot ds is equal to, as these all are constants, q by 4 pi r square closed integral of ds, which is equal to closed surface integral of d dot ds is equal to q by 4 pi r square dot s. Here s is the area of the sphere. We know that area of sphere is equal to 4 pi r square. Let us substitute, that is surface integral of d dot ds is equal to q by 4 pi r square and s is equal to 4 pi r square, which is cancelled. Finally we will end up with surface integral of d dot ds is equal to q enclosed. In this way, we will prove that closed surface integral of d dot ds is equal to charge enclosed by the surface according to the Gauss law. Now let us see applications of Gauss law. Now let us see application of Gauss law in calculation of electric field. Electric field due to a point charge. According to Gauss law, let us take a charge q enclosed in a closed surface with a distance from the sphere is r. Its electric field will be outside the surface like this in all the directions. That is, we know that according to Gauss law, closed surface integral of d dot ds is equal to q enclosed. Now let us split it into closed surface integral of E dot ds is equal to q by epsilon naught, where we know that d is equal to epsilon naught times E, as E is an electric field. That is, now let us take a differential element of which electric field will be outside the direction. The angle between electric field due to point charge and a differential element charge is in the same direction. That is, E and differential element direction dE are parallel, so angle between them is equal to 0. As this element is in the surface, that is, E ds cos theta is equal to q by epsilon naught, where E ds cos theta, cos 0 is equal to q by epsilon naught. We know that cos 0 is equal to 1, E ds is equal to q by epsilon naught. As the ds is the surface, here it is a sphere, we know that area is equal to, as it is an integration, surface integral E dot ds, that is E times ds is equal to q by epsilon naught, which is equal to E times of s, where s is a sphere of area 1 by, this is 4 pi r square, s is equal to 4 pi r square. When it comes to this side, this is equal to 4 pi r square times q by epsilon naught. And as it is a vector, so let us take a vector ar cap. This is the electric field intensity due to a point charge according to the Gauss law, and we know in the previous equations it is same to it. Now let us do for a line charge. Now let us do calculation of electric field due to a line charge. We know that electric field due to a line charge is equal to rho L by 2 pi epsilon naught times r into r cap, which is an unit vector. Now let us find it using the Gauss law. Let us take a line charge rho L with a positive charge on it. Now let us consider a cylindrical surface around it. That is, Here we have three regions, that is bottom, top and this curved surface. Top, bottom and this curved surface. We know that electric field direction of this line charge would be in this direction. Here bottom surface direction would be in this direction and the electric field would be in this direction, and the angle between them is 90 degrees. And the same way direction of surface would be in this side ds, and the angle and the electric field would be in this direction and the angle between them is 90 degrees. Here let us take a differential element of ds and these two are parallel, so angle between them is equal to 0 degrees. Now let us split it for, we know that d dot ds closed surface integral of is equal to q enclosed according to Gauss law. Let us write this as E dot ds is equal to q by epsilon naught, and split this as per the regions. Surface integral of E dot ds, for this it is a top direction, plus closed surface integral of E dot ds for bottom, and for the curve E dot ds for the curve. That is equal to closed surface integral E ds cos theta, E ds cos theta, closed surface integral E ds cos theta. Here theta is equal to 90. We know that cos 90 is equal to 0. That is, it is equal to 0. This is equal to 0 as theta is 90. Here theta equal to 0. So that is equal to E ds, which is of 1. That is closed surface integral. As E is not in the terms of S, E would come out, and closed surface integral E ds is equal to, it is charge by epsilon naught. It is equal to E times of S is equal to Q by epsilon naught. Here the surface is in the direction of cylinder, which is the radius of R. We know that area of the curve is equal to surface is equal to 2 pi r times of L, as length is L. That is E is equal to Q by 2 pi RL times epsilon naught. We know that charge by L is equal to line charge density. Line charge density. Let us substitute it. That implies E is equal to Q, in Q by L would be replaced by rho L by 2 pi r times of epsilon naught. As this is in the directions, we have to take the vectors, that is unit vector, and this is the final equation. As we have discussed from the previous conditions, which are same, we have proven this using the Gauss law. In this way we apply the Gaussian surface and Gauss law for different derivations of the charges. Thank you for watching. Like, share and subscribe to Everything You Need. Thank you.